The last application for 8.5 will be cryptography. So matrix multiplication can be used to encode and decode secret messages. Okay, so say you wanted to send this secret message to your friend, but you wanted to make sure whoever intercepted it could not easily decode it. Okay, so first I'm going to translate this message into numbers. This is the list. I put it here for those of you who have trouble with the alphabet, but A is the first letter of the alphabet, B is the second letter of the alphabet, and so on. So if I wanted to translate this to numbers, where is H? H is 8. I is 9. There's a space. I use a 0 for a space. C, A, T. And yes, you could count all the way to T, A, B, C, sing the little song and count all the way up. Okay, now I have an encoding matrix. This is my matrix that I'm going to use to put this into code. Because my encoding matrix is a 2 by 2 matrix, when I rewrite my secret message, I'm going to put it into 2 columns in my secret message. Okay, here, I can't talk about it at the same time. Okay, I want to have 2 columns, but I'm going to put those numbers in order going from left to right. So I'm going to say 8, 9, 0, 3, 1, 20. And if there had been an extra space here, I would have just put zeros in all the blank spaces. Okay, I'm going to multiply this by my encoding matrix so that before I send it to my friend, it's already encrypted so no one can easily translate it. Okay, if I don't match the columns to the encoding matrix, when I do the matrix multiplication, it won't work. So I'm going to do row by column. Let's see, 8 minus 9, 0 minus 3, 1 minus 20. Okay, now I'm not going to send the message as a matrix because it kind of gives a hint to how it was encoded. So I'm going to relist the numbers in a row before I send my message. So -1, 11, -3, 9, -19, and 58. Okay, so this here is my encoded message. I'm going to send it to my friend. Apparently my friend is Cat. And then my friend is going to somehow decode it. Okay, now how is my friend going to decode it? Okay, first my friend has to know what the encoding matrix is because my friend has the same encoding matrix. To decode the matrix, they need to find the inverse. Okay, so why is this good? Because even if someone accidentally finds my encoding matrix, unless they know pre-calculus, they're not going to know how to find the decoding matrix. So I'm going to use augmented matrices to find the inverse so I can decode this little message. Okay, so let's do 1, -1, -2, 3, and I'm going to augment that with the identity matrix. Remember, I'm trying to get the identity matrix on the left so I can find the inverse. I will leave the first row the same. And I'll add the rows to cancel that first element. 0, 1, 1, 1. What's left? Let me get a 0 here. Okay, let me check. I actually already have ones along the diagonal, which is perfect. So because this is the identity matrix, this must be my inverse matrix or my decoding matrix. Okay, so to decode it, I'm going to use this inverse matrix. Okay, now that my friend Kat has found the decoding matrix, they're going to encode the message I sent them because they don't know what I wrote yet. Okay, because they know the decoding matrix is 2 by 2, they're going to rewrite the encoded message in columns of 2. 2 columns in 2 columns. Left to right, -1, 11, -3, 9, -19, 58. And because they're trying to decode it, they're going to use the inverse. And then they're going to go ahead and do their matrix multiplication row by column. Okay, my friend did their matrix multiplication. They showed a step. Even SPY show their steps. Okay, and then I see the final matrix I have, I'm going to rewrite it in a row so I can decode it. Okay, and then I'm going to go look back up to my alphabet list, or I'm going to say the alphabet in my head. The 8th letter of the alphabet is H. I. 0 just means leave a space. C. A. And the 20th letter is cat. The 20th letter is T. Okay, so the decoded message is hi cat, and my friend has properly received the message. Okay, now we're going to pretend like I don't actually know what the message is ahead of time. So someone sent me this message. I'm going to decode it, and I'm going to use the same matrix as before. Because it says decode, I'm trying to undo the code, so I'm going to use the inverse, same one as above. And because my decoding matrix, which I'll write it on the side because it's not on my screen anymore. Because that's 2 by 2, when I write my message I'm trying to decode, I'm going to put it in 2 columns. So 11, -7, 2, 9, -13, 39, 5, -10. And again, if there had been an extra space with no letter, I would put a 0 in the extra space. And I'm multiplying by the decoding message. Okay, I'm going to go ahead and do my multiplication. Okay, and of course, I'm showing a step to make sure I don't make a mistake. Okay, so I have the decoded matrix. I'm going to write it in a row. And then I'm going to check my alphabet list, or I'm going to say the alphabet a bunch of times in my head. Okay, the 26th letter of, well, that's Z. Last letter of the alphabet, Z. Yep, say the alphabet. There we go. O, O, 13, M. 0 just means leave a space. There's an M again. For 5, A, B, C, D, E, E. 0 is a space, so my decoded message is Zoomy.